The first thing I want to do is just mention a little bit about Mars and Wrigley, so there's some familiarity with what we're dealing with because there's so many different industries. Mars is a family-owned business. Most of you are familiar with their M&Ms. They also are in the pet food business. They have distribution, vending machines, several different business segments, and Wrigley is now a unique subsidiary as an independent business unit of the company. William Wrigley Jr. Is a family-owned business as well. Was started in 1891, selling baking powder and soap in Chicago. Products are sold in over 180 countries, and we've got manufacturing facilities in 14 countries. As of October of last year, the two companies merged and have now created the world's largest confectionery company. And we'll see how long that holds, pending what happens with Cadbury and Kraft. Just a little trivia on the Chicago connection, because we're all here in Chicago. Mars has a production facility that they built in Oak Park, Illinois, that still exists there today. It's a historic site. We also have a factory in Burr Ridge, Illinois, that produces Dove ice cream. So if you're ever in the area, they do offer some tours, which is a pretty unique facility. William Wrigley Jr., most people know the Wrigley Building, right across the street in Michigan Avenue. And then obviously you guys are all familiar with the history behind Logic Tools, ILOG, and now IBM. What I want to do today is just share with you a little bit about some of the work that's been undertaken within Wrigley, and then also now a broader effort that's underway within Wrigley/Mars. Talk to you about some of the tools that we've used, and then share with you a distribution case study within the company, also share with you a manufacturing case study, and then talk to you about some of the lessons that we've learned. We've looked at two different components of network design, manufacturing and distribution. And what we've really looked at from a focus side is really identifying and exploiting any of those structural cost advantages that we have globally. Some of the questions that we've been asking: how do we support future market growth, organic and acquisition related? Where do we expand? When do we expand? How many plants do we have? Where should they be? What should each supply? We've even used some of the tools available to look at what technology platforms we should use. Should we be using one technology platform in developed markets and a different one in developing markets? Should we produce our own products, or should part of it be outsourced with external partners? How many DCs do we need? Where? What should each store? And which customers should each of them serve? We've spent a lot of work trying to utilize the tools available to evaluate trade-offs that we have in making the decisions and how we move forward. So how do you balance efficiency versus flexibility? How do you look at cost versus service levels, and so on and so forth? One of the questions that we have spent a lot of time looking at is, what is the frequency at which we would undertake different network design activities? And we've structured it in a few different ways. On one hand, we look at an annual review that's necessary based on looking at revised business plans, the annual review of what the demand might look like for that next year that you're committing to deliver. And then also looking at more strategic exercises. So if there are any what-if scenarios that we want to be conducting on an annual basis, we look at building that into part of the annual review, as well as risk management. So you can share some examples. Last year, looking at the earthquake in Chengdu, China, just over the last week or two, looking at what's happened within the Philippines, we've utilized a lot of the models that we've built to look at what-ifs like that and saying, if there was some sort of a natural disaster to occur, and we lose the ability to utilize some of our manufacturing facilities for a certain period of time, do we have enough redundancy built into our network to help compensate? Or to what extent are we opening ourselves to risk because of the inability to service a certain amount of volume within a year? And then we also look at frequency from an event-driven standpoint. Mergers and acquisitions is a perfect example right now, because Wrigley had undertaken some modeling exercises as an independent company for a while to look at revisiting our manufacturing footprint and then distribution footprint. But now with the integration that we're underway with Mars on, it's thrown some different dynamics into the picture. So with some of the manufacturing work that we had done, we had a 10-year roadmap that was developed that was helping us understand when would we need to bring new capacity online, and in what parts of the world would we choose to bring those online. Now with Mars, we have a tool set, some existing models that we already have available to us, where we can start doing some integration on the Mars side and say, well, how does Mars change that picture? are there different expansion opportunities that we would build in today that we didn't know about a year ago? We've also looked at some scenario and project-driven types of needs that would influence us to look at different network design activities. And this is sourcing of new products. So if we have a significant new product launch that we know we're going to be planning, we may choose to use the models that we've developed to look at what type of sourcing strategy would we want to put in place short-term and then long-term to help support that launch, as well as looking at external manufacturing. If we want to scale back on some external manufacturing or we want to look at expanding more with external partners, utilizing the tools to help us understand what does that mean to us from a total cost standpoint. Some of the factors to consider that we've been building in here, and most of you that are already using some of the tools are very familiar with this: market demands and trends, currency exchange volatility, duties, labor rates and inflation, and a multitude of different costs. And before coming to Wrigley, I was actually doing strategic planning before and building models in Excel, which was great because it helped meet some of the needs that we were looking at. But in terms of being able to look at all these factors to consider in one place and very easily change them from a sensitivity standpoint and look at the results, it was very difficult for us to do that in a quick period of time. And so that's one of the benefits that we've seen in moving forward with using LNP, because we have been able to take all these factors into consideration and look at, for example, if we want to build a new factory somewhere in Asia, and we know that the inflation rate is a certain factor in China, and maybe it's a different factor in Vietnam, a different factor in the Philippines, and we try and project that 5-10 years out, what does that really mean to us? Does it help guide us in terms of looking at which country we would choose to put another factory in? Another thing that we spent a lot of time looking at was, do you use past costs? Do you use projections? What do you do in the models? And we've actually looked at using both. When we build the baseline models, we're looking at historical costs from a certain period of time that everybody's aligned on. And then we look at that future vision. There's a certain amount of looking at what we built into the budgets. Do we think something will go up 3%? Do we think something will go down 1%? But then we try and stretch beyond that and say, okay, if we're projecting a certain growth rate, what if we see triple that? What if we go negative and we hadn't anticipated it? That way we're really stretching ourselves and trying to understand with the recommendations that we have coming out of any of the work that we're conducting, how robust are those recommendations under different sets of conditions. We create scenarios. We identify the most favorable scenarios, and those are the ones that we focus in on to conduct a lot more sensitivity testing. And then we select and actually ultimately recommend the most robust solutions. In terms of the tools that we were using or we have used, we use LNP, LogicNet Plus. We use Transportation Analyst, and we're actually just now beginning to use Inventory Analyst. One learning that we have that I will share with you is in the early work that we were doing within our distribution and our manufacturing footprint, we weren't using Inventory Analyst. We were looking at doing everything within the tools except an inventory evaluation, and then out of model, on an Excel spreadsheet or rule of thumb, trying to figure out, okay, now what would be the inventory impact of some of the changes that we're making? If we add a DC, if we remove a DC, what does that do to us? And especially complicating it, looking at Wrigley and Mars coming together, you can imagine how many heated debates there might be on, well, what is the inventory implication and how are you operating? And so we see that as a key win in trying to help take some of the argument out of it and help us move through a smoother process in terms of aligning on what we think the ultimate impact of some of our network changes would be. From a distribution case study side, what I'm sharing with you here is a study that we just recently completed that was a joint effort between Mars and Wrigley. What we were looking at was our distribution network within North America, and we were trying to understand what would be the optimal network for us at some point in time in the future. And for us, our horizon was 5 years out. So we were starting from a baseline off 2008 data and then scaling that to look at how should we really be operating in a 2013 world. The scope for us was the U.S. distribution network, but we were also accounting for demand and production that was taking place within Canada and Mexico. All of our North American plants and DCs, co-manufacturers, co-packers, and we were looking at all of our customer demand aggregated up to a 3-digit zip level, and we were also identifying our McLean customer separately so that any distribution network changes that we might see coming out of this study, we could understand in aggregate how it might impact customers, but also specifically how it would impact McLean because they were such an important customer to us. And all relevant modes of transportation were included. From a scope side, it's important to point out that what we were really looking at was a combined 1.9 billion pounds of demand, over 2,000 SKUs, 50,000 transportation lanes, and 100,000 bills of lading. So there was a great amount of complexity that we were looking at within the Mars-Wrigley confectionery world, and the key for us was aligning on how do you effectively aggregate everything up to a level that's manageable in terms of being able to run your scenarios and really simplify the results as we look at undertaking different scenarios to evaluate. The project flow that we typically use for every study that we do is kick off the project and undertake a data collection phase. And the data collection can range from 3 weeks to 2 months. It's a matter of figuring out if you've got the right people identified and committed enough to deliver the project. And then we go into data analysis and validation mode. We develop a baseline model and sign off on that model. And then we create an optimized baseline. The baseline and the optimized baseline I'll touch on here in just a moment. And then we actually run our scenarios and ultimately deliver final recommendations. From a project team standpoint, we typically have all of our studies structured in a similar manner. We've got a Mars-Wrigley lead, a single point of contact to the customer, and they're interfacing with IBM. And I won't read through it, but you can see some of the typical tasks that are delineated between the different components of the project team here. And then the Mars-Wrigley lead is interfacing with an internal steering committee, which is really gauging us on any of those critical decision points that we get to along the way, or any constraints that we need to be building into the way that we're operating. For example, if we know that we want to undertake a distribution optimization study, and we know that there are certain things that we can't change because they would be transparent or impact the customers, then we do build that in. Beyond that, we want to try and minimize the amount of constraints that we're building in so that we're really challenging any of those preconceived boundaries that we've typically had historically in how we operate. And then we've got the interface to the core team, which is really focused very hard on the data collection, the data validation, and so on and so forth. From a network modeling process, some of the key learnings that we've had along the way is most importantly, first and foremost, it's defining the key questions that you want to answer first and then building the models. And I don't know, many of you have had similar experiences to what we had, but the first time we went through and we undertook a manufacturing network study, we went to such a granularity of detail. We didn't want to aggregate our products to a point that maybe made a little bit more sense for us. And so we argued as much as we could with ILOG at the time to try and keep that level of detail in. Pack type, gram weight for products. And you can imagine the number of products that you were looking at that point, and the implication that it would have then as you start building in your supply capability within the models. And then we carried that over into the first distribution study we did. And if you think about it, that level of detail is not at all relevant to trying to figure out how to optimize your distribution network. So built in a level of complexity that really made it difficult for us to maintain the models. And even in terms of processing time or looking at analyzing your results was quite difficult. So I'd say one of the key learnings for us really was, define the questions you want to answer first and let that drive how much complexity or how much granularity that you build into your models. And then the next point on here really is going through that process of baseline to optimize baseline to running scenarios. We went through an exercise in actually developing our baseline and then looking at running the model and comparing it to our financials, if you will, to make sure that there was a fair amount of confidence with the success in what we were seeing the model was outputting. And the interesting thing that we found was when we ran when we collected all the information and developed our baseline, we were astounded by how many inefficiencies we were seeing in the way that we were already operating. Nobody's perfect, but I think until we went through that, we weren't realizing how many areas there were for us to actually improve before we started talking about any changes to our network. And this went to the extent of stock transfers, DC to DC transfers that we were doing because we just we weren't forecasting our demand accurately at a DC location level. Efficient trucks is one example we had, where we thought that we were shipping or moving full trucks. They weren't actually full trucks. They could have been fuller. So what we actually found going through this whole exercise was a tremendous amount of value in just building the baseline model to help us understand how are we really operating today, and it helped us identify some quick wins before we even got into that modeling of any scenarios. For example, with the Mars-Wrigley exercise, we found that there was such an extent of manufacturing that Wrigley was doing in Canada to support the U.S. market. And on the flip side, Mars had a tremendous amount of production being done in the U.S. that was then crossing the border to serve Canadian customers. So right there was some tremendous cross-border continuous move opportunities that we had for savings. And so really putting the time in on the front end for data validation and looking at validating your baseline, we were able to uncover a lot of opportunities in the way that we operated already. Then we went into creating an optimized baseline, which stripped away all those inefficiencies, which was critical for us because if we were changing things in our network, if we were adding a DC or taking away a DC, we wanted to look at that very uniquely and not be building in any of those inefficiencies in the way that we operated. And so what I've indicated here is from a realized savings side, it's been pretty consistent in all the projects that we've done so far. We've found more savings opportunities in improving the way that we were already operating that far outweighed any of the savings opportunities that we had in actually moving forward and making any changes based on the scenarios that we chose to run. If you look at plant and DC locations that we have within the U.S., you can see that production locations are pretty unique. It's a little bit hard to see, but the squares indicate the Mars and Wrigley plants, and the circles indicate our distribution centers. What was interesting was to see how much significant overlap we had in our distribution centers. In 3 locations, in one location, we were in the same building on opposite ends of the same building. In the second case, we were across the street from each other in the same building. And in a third case, we were 20 kilometers apart. So there were some real clear synergies that we already saw from the very beginning, which made sense in helping to understand why there was an acquisition that was made to begin with. And then if I go even further and look at customer demographics, there's a significant amount of overlap in customer demand density. You can see Mars on the left, Wrigley on the right, and similarity in our overall sourcing networks, the external partners that we chose to use, co-manufacturers or co-packers. One thing that was a challenge for us that we found, whether we were looking at just Wrigley or Wrigley and Mars together, was making sure that everybody talks the same language. We found early on that a stock transfer at Wrigley isn't the same definition as a stock transfer at Mars. And we found a lot of challenges in looking at different things like demand. Demand in a Wrigley world is an SSU, a single serving unit. What does that mean to anybody else outside of manufacturing? Nothing. So it was trying to translate everything back into a common denominator, pounds of demand. And that was where we struggled initially in trying to make sure that we were as strong as possible in our data management. So really linking up to our DMO counterparts was critical in the success of any of the projects that we've done. So what we actually saw was we had a clean slate where I think we were looking at about 25 hypothetical DC locations within the U.S. And we opened the model to everything, saying, okay, if we have anywhere from 1 to 9 DCs, where should those be located? And what this is showing you is a summary of, for the number of DCs that we had, what is the total cost on the top chart there? And on the bottom, it was showing us the percent of demand weight within days of transit. So what does that tell you right off the bat? In terms of looking at the point of diminishing returns, you can see that slope between that 4 to 6, 4 to 7 number of DCs. And if you look at it below, the interesting thing is Wrigley had been operating in a 3 DC network. What does that mean? About 64% of our demand was within a 1-day transit time. If we moved more towards an approach of looking at 5 DCs perhaps, we can improve that up to 71%. And in that case, well over 90% of our demand was within a 2-day transit time. So this was interesting for us just in terms of trying to understand from a total cost perspective what was the real impact to us and then the impact ultimately to our customers in transit time. What's not reflected on here is the inventory impact of making any of those DC changes, incremental DCs or decremental DCs. And again, we built that in, we took that into account offline. So then, looking even forward at a customer service side, we drilled really into looking at a 5 DC network and what did that mean to us. And what we saw was the weighted average distance to all of our customers in aggregate decreased by 200 miles. And we were able to improve the alignment within distribution centers of our major customers. So in our 3 DC world, about 50% of our DCs were within a 1-day transit time of our major customers. If we move more towards a 5 DC approach, 90% of our major customer DCs would be within that 1-day transit time. So this was critical to us because anything that we wanted to implement, any change, this was a key selling point for us to take to our customers so that they would understand any of those implications as we started going through that implementation. Then we were also able to look at a lot of different things like fuel price volatility. Who knows what's going to happen in the future, but it's always helpful to get some view of, well, what if, what impact does it have on your network? And so we looked at current prices at the point of time that we did the study last year. Then we looked at what if we go up to $200 a barrel? What if we go up to $300 a barrel? So if there was any question hovering between that 4 to 6 DC mark, you know, how do we really view the future? You could see at least we're you know, being pushed more towards that 5 to 6 DC number away from that 4. So for us, we saw really for every $100 barrel increase in the price of diesel fuel, we would need to consider adding 1 additional DC. That's only unique to us. Every company you know, is going to see something different, but it was a good awareness level for us so that the more that we knew about what we think might be happening in the future, if we were on the brink of how many DCs, it helped, you know, really push us into, okay, maybe, you know, if it's between 4 or 5 or 5 to 6, let's, you know, take the additional direction of 1 more because we know we'd be better served in the long run. And then we also took a view looking at the number of DCs from a sustainability side. And what we saw here was if we had fewer than 5 DCs, we had increased CO2 emissions due to the increased number of network miles. If we had more than 5 DCs, fixed emissions with each facility increased emissions. So we saw really for us that sweet spot from a current standpoint was 5 DCs. And then from a complete financial impact of this effort for us, what we actually uncovered was total savings opportunity that varied between 5 to 9% of our total logistics spend. And we really bucketed that into 3 different areas. One was looking at warehouse synergies and consolidation, and that was about 1/3 of our savings. The second, and that was really what we regard as one-time savings. The second bucket was looking at common systems, leveraged volume, any kind of supply chain synergies that we had within the network, and that was about 20% of the savings. And then the big piece for us was really looking at an opportunity for shipment consolidation. And shipment consolidation alone was almost half of the total projected savings that we saw in terms of looking at a more integrated network between the 2 companies. Breaking that down even further, we know from an implementation side, going after the savings isn't free, so it comes with a price. And with the work that we had been doing, we looked at that price, that investment that we would be needing to make up front as being about 1 to 2% of the total savings. So from a net standpoint, we'd be varying anywhere from about 4 to 7% of total logistics spend, which is quite significant, you know, depending on the magnitude of your total logistics spend. And again, we spent a lot of time looking at inventory. How do you value it, and what are the offsets that you might see in terms of looking at incremental or decremental number of DCs in your network? And we looked at risk. if there was any question about 4 or 5 DCs, and we didn't think that we were going to see any real improvements in our ability to forecast demand in the short term, were we better served by having an extra DC so that we have more flexibility in terms of being closer to the customer and have a higher response rate. And also, we were breaking it down into short and medium term implementation. So obviously, if you want to make some structural changes like adding a DC, removing a DC, it doesn't happen overnight. So we were looking at phasing over a 5-year period of time. How would we choose to tackle some of those savings? And part of it also was looking at the opportunity for organizational changes as well to help expedite some of that. So the key takeaways for us really in this whole effort were, 1, what order should activities occur to actually minimize the risk and maximize the savings once you know what you want to move forward and implement. And then 2, what's the investment required in time, people, and money to achieve those savings? And is everybody within the organization aligned? The next piece I want to share with you here is a manufacturing case study that we had done. And this was a unique Wrigley effort prior to any of the Mars effort underway. And what we did is we really looked at 3 overarching business questions that we wanted to answer. 1, we wanted to understand what do we need to do in terms of meeting the needs for new capacity and sourcing changes. So the way that we were operating at one point in time, if we assumed at a certain time period we would double our business, what would we have to do on a supply side to support that? And given the way that we were structured, is it really reasonable to think that by doubling your demand, you would just duplicate your current sourcing network? Double the number of plants that you have for us was absolutely unrealistic, and meant from the beginning we had to start thinking about a different way that we would approach designing a manufacturing network that would best serve the needs of the company to be able to commit to meeting that type of demand growth. And what we wanted to understand was, in the more decentralized world, looking at regions separately, if we looked at a region independently and we came up with a solution for how you would meet their demand growth, if then you took a step back and you looked at it in a global view, would that be consistent? Would the solution be the same? So we wanted to understand recommendations for new capacity and sourcing changes from a regional view and then from a global view. Second, we wanted to understand whether there are any cross-regional sourcing opportunities that may exist that we weren't already utilizing within the company. And then third, do we expand or do we consolidate that manufacturing network? So this was really a slightly different question, but it was looking at, in the long term, are we better served by having many new smaller plants all over the globe? Or ultimately, should we be thinking more about a strategy where you look at creating 1 or 2 mega factories per region? So how did we do this? The approach that we took, we developed a manufacturing model for each region, North America, EMEAI, Asia Pacific, and then Latin America. And in each case, we were building in any expansion opportunities or even closure activities. So we weren't just looking at where would we build the next plant and how big would it be, but do we have current plants within the network that were better served by closing and then using a new facility somewhere else to help supplement that. So in each of those regional models, we were running many different scenarios. And then after that activity was completed, we rolled all those regional models up into one global one to help rerun everything and see what the view would look like. And in aggregate, you can see we were talking about 26 plants. So this was Wrigley factories, some of our key external contract manufacturers, and some potential plants in different parts of the world that we wanted to evaluate. From a global perspective, we had to take a slightly different approach because we didn't really have a typical baseline to validate, run an optimized baseline, and then run scenarios. So what we actually did is the baseline scenario that we started from was, in essence, it was representing the global optimal scenario that we had with no links to the regions. Every region was independent. And then in an optimal world, we created those linkages between all the regions to see what the effect would be. And then we were comparing the optimal versus the baseline to really look at any of those incremental cost savings that we would see by some of those linkages between the regions. And this was really important for us in terms of understanding to what level do you want to build flexibility into your network. So are we better served by having some level of flexibility so that you could have cross-regional sourcing? But there were also some learnings that we had coming out of it that, quite frankly, we probably should have had before, without having to run the model. But this was an enabler for us to uncover some of those opportunities. For example, we were sourcing a lot of our markets in Dubai out of Western European plants, and we thought that was lower cost. We thought it was shorter lead time. The model was actually spitting out a different source for us, and when we went in and investigated it, we did in fact find that there was a much lower cost alternative and a much shorter lead time for us than the current factories that we were sourcing that market from. So again, it was great for us in terms of looking at identifying some low-hanging fruit, some quick sourcing changes that you could make relatively easy to go after some savings, but then also looking at some structural changes within your network that would take a much longer time to implement. And again, here we were looking at a 10-year horizon compared to a 5-year horizon on a DC side because of the lead time that we have associated with some of those network implementation of change. And then finally, from a lessons learned standpoint, there's a couple of key takeaways that I want to share with you here today. One, I mentioned already earlier, just the importance of defining the key questions that you want to answer, or you want to ask and you want to get an answer to first, and then go about determining how you build those models. And just something that I will add in as another example here on the level of flexibility in what you choose to do. When I shared the distribution study, we fixed production for the Wrigley factories because we had already finished a manufacturing optimization exercise. So we were purely focused on the DC side. Within Mars, we built in some level of flexibility on a production side so that we could go through and look at, okay, which factories should be producing which products, and does that require us to do some capacity expansion work above and beyond the way that we currently are structured. So there was an ability for us to look at optimizing from a manufacturing and a distribution side within the same model. But again, getting that clarity up front and what your objective is was critical for us in terms of figuring out how we go about structuring it. Second, again, don't build in more complexity than necessary. It creates more heartache. And more than anything, it impacts your ability to be able to sustain what you've developed long term. So the simpler, the better. And we found that in terms of aggregating and making models more simple, we're not giving up anything in the end in terms of results. Data required can be very hard to collect, and consistency is key. So this is one thing that we found that was a huge challenge as we were looking at pulling data out, not just between Wrigley and Mars, but even between the regions. If we were pulling something out in Western Europe and we were pulling something out in the Pacific, were they structured, even from a DMO standpoint, where we could pull the same report and what was really giving us the same information? Spent a lot of time going through and making sure that we were speaking the same language. Don't skimp on validation and analysis. Because this is so critical to being able to fully explain the results. In our experience, what we found is we probably spend about 60% of our time validating data and analyzing that data, and maybe 10 to 15% of our time analyzing the results of the scenarios. You would hope that it would go the other way around, but what we found is we absolutely have to put all that focus in on the front end. And if you do that, when you get the output of the model, it's very easy to go in and internalize what the results are telling you. Does it make sense? Does it not? If it doesn't, is something wrong with the model? Most of the time it's not. Most of the time it's just a precondition that we've had in the way that we've operated over the last 10, 20 years maybe, that we do need to step back and challenge. Modeling is only the first step. So there's remaining uncertainty and soft factors that need to be built in. We've also encountered situations where we've developed our final presentations and our recommendations, and people are ready to just go implement immediately. And knowing there are other factors that need to be built into the mix, any geopolitical risks, other things that are unknown that you need to discuss, that you aren't able to really build into the model. So keep in mind that the output of the model is really only the first step, and what we found is it was so critical more than anything in enabling those strategic business discussions throughout the business that without going through this exercise weren't happening. Next, organization structure is critical. It influences your ability to see continuity, maintain linkages throughout the organization, and more importantly, knowledge retention. We've gone through a tremendous amount of change in terms of how we're organized internally to be able to build on the work that's been done to date and sustain that going forward. And I definitely would be more than happy to talk more about that later on this afternoon, and hear, how are some of you approaching organizational structure within your organizations to try and make sure that you can maintain and build on your network design efforts. And finally, the last point is, this is really hard. What we found is we're crossing organizational boundaries within the company to try and do this work. We're challenging preconceptions that people have about the way that we should be running the business. And more importantly, a lot of the changes that we're finding we actually should be implementing can be disruptive and in many cases unpalatable. So a lot of times we find we have a clear direction on an opportunity that we can take moving forward, but we choose to leave some savings on the table because sometimes it's just too much for the organization to take at once. So that's another benefit, I think, in terms of looking at an endpoint, picking a point in time in the future for how you could exist, and then look at a phased implementation. How would you get there over time to make sure that you don't have too much disruption in the business, and by doing that implementation, you really are being able to recoup all the savings opportunities.